Hello students, welcome back. Um, we are going to handle another question which is again dependent on Heisenberg uncertainty principle, and the question is what is the order of electron energy inside an atom? Okay, so in the last example numerical we have seen that in beta decay the order of energy of electron coming out of atom is 4 mega electron volt. So the next question that we can ask ourselves, is this the normal energy that electron has inside an atom? So let's take the example of hydrogen atom. Okay. So okay. The question is, what is the order of electron energy inside hydrogen atom? So let's see what answer Heisenberg uncertainty principle gives us, and we will try to uh, reason it out. Okay, so what are the facts that we know? The first fact is mass of electron is 9.1 into 10 to the power minus 31 kg, that we already know. The second fact is radius of hydrogen atom is of the order of 0.53 angstrom, that is 0.53 into 10 to the power minus 10 meters. So if this is nucleus and this is our atom, what we are saying is that this radius of the atom is of order of 0.53 angstrom. So electron is not inside this nucleus, we know that. It means electron is somewhere here, right? So it may be here or it may be here. So if you look from nucleus, if you are standing on nucleus and you are looking around, electron has to be somewhere up to this distance from you, right? So we can say that if we are going to apply Heisenberg uncertainty principle, we can say that the uncertainty in electron's position from nucleus is of the order of 0.53 into 10 to the power minus 10 meters. Okay, so for applying Heisenberg uncertainty principle, I know this thing from this fact number 2. Okay, let's apply Heisenberg uncertainty principle, that is delta x delta p should be of the order of h cross. Okay, it means delta p would come out to be h cross by delta x. This would be h cross is 1.05, so now you can remember it, 10 to the power minus 34. I am directly writing h cross, that is h upon 6.28, h upon 2 pi, and delta x is 5.3 into 10 to the power minus 11. So delta p would come out to be somewhere around 2. It is 1.98 into 10 to the power minus 24, so you can write it 1.98 into 10 to the power minus 24. Okay, now we want to know the energy of electron. So what is the formula that we are going to use for energy? Let's stick to kinetic energy formula. So we know that kinetic energy can be given as p square by 2m. So it would be p square is 1.98 into 10 to the power minus 24 square by 2 into 9.1 into 10 to the power minus 31 kg. So I have put m is equal to this. Oh, okay, it comes out to be kinetic energy of electron come out to be 2.16 into 10 to power minus 18 joules. Okay, so kinetic energy in electron volt would be 2.16 into 10 to power minus 18 joules by 1.6 into 10 to power minus 19 joule per electron volt. So kinetic energy of electron would come out to be 13.5 electron volt. Okay. Now, if you remember, actual kinetic energy of electron in hydrogen atom is 13.6 electron volt. Of course, its total energy is minus 13.6 electron volt and its potential energy is minus twice of 13.6, that would be 27.2 electron volt. Okay, so let's look at this result. So Heisenberg uncertainty principle has given us a result that is so close to the real value that it's almost amazing how this simple formula can predict things about the electron and atoms in such an amazingly precise way. Of course, it is because of the very small value of Planck's constant. Okay, so one thing I would like to point out here is that the kinetic energy of electron in a hydrogen atom comes out to be about 13.5 electron volt, whereas in beta decay we have said that this is an established fact that the kinetic energy of electron in beta decay is about 4 into 10 to power 6 electron volt, 4 mega electron volt, and this value, electron revolving around the nucleus in an atom, is only about 13.5, right? So this is a large discrepancy, right? So what it is saying, so this is a fact that electron energy in its orbit is of the order of 13.5 electron volt. Electron cannot reside inside a nucleus because it has to have an energy of 95 mega electron volt and it has to have a velocity greater than velocity of light, so it cannot exist inside the nucleus. And there is third fact that in beta decay an electron comes out of the atom with a kinetic energy of 4 mega electron volt. So what is happening here? Okay, to understand that, we have to actually go into another physics. Quantum mechanics itself is not giving the answer, right? So there has to have another physics which is known as nuclear physics. So the answer would come from there. Of course, nuclear physics is another application of quantum mechanics, but there is another physics of nucleus itself. Okay, so this is the point that I wanted to bring out. Okay, hope it helps. Thank you.